Okay, welcome, Zabai and Crystal and Riley and Zach and Allison and Elena and Sophie and Zach again, and Alejandra and Charles and Bailey and Hannah and Kalina and Aniseta and Constance and David and Mackenzie and Juliana and Abigail. It's a good group. It's nice that we have a lot of you here. It looks like at least Tuesday evenings aren't a terrible time because a lot of you are able to make it, which is good. So I want to let you know what we're doing today. This is the week 2 webinar. And what we're going to talk about today are 2 main things. The first is probability. And as I've mentioned a few times with announcements, it's a tough chapter. It's not very detailed, but it's hard because there's going to be word problems or word questions at which you're going to have to decipher the vocabulary and know what to do. And that's usually the hardest part, is the deciphering the words. The math itself is really easy. It's division and maybe powers, and you get a calculator. So that's not going to be the problem. The problem is trying to figure out what math you need to do. That's where the tough part comes in. There's a lot of words, and you have to know what the words correspond to mathematically. That's the tough part about chapter 3. And I'll do my best. Please ask questions as you get confused about things. And then the second part of what I want to do today is project 1, sorry. So what I want to do is I want to really go over what the expectations are on project 1 and what is a good plan of success for all of you. Again, I want y'all to do well, and I'm going to give you some guidance on how you might do well on the project. And I'll let you know what goes wrong. And there's a lot of things that go wrong, so listen carefully. This is a real important webinar in terms of the project, because this is where I tell you all the things that go wrong. Okay, it's a little more than just what's written out there, but all the stuff where people have trouble with. So are there any quick questions before I move on and get into probability? Any questions? Okay, I think what I want to do, and I want to remind you, by the way, I forgot to, but remember this gets posted on YouTube, so I'm fine if the whole world sees my face, but let you know that you will be shown. You have extra time given for tests. So if you are again, if you have a disability, and that could be a learning disability or a physical disability, you contact our Disability Resource Center. And that's linked from the syllabus. It's also linked from the first module. And they will make sure you get what you need, and it will happen. And then you have to communicate with me on what the needs are too. Does that make sense? So they communicate with me, so it all works, but you need to talk to them. And what they do is if it's already been established at your college, at somewhere else, then they just say, great. But they talk to your college and make sure it happens, is the way it works. Any other questions? Any other questions? Okay, so what I'm going to do, and we're going to go, I think everyone can see all the names, right? I want to keep the names up here. And I want to talk about probability, and I want to use you guys for the probability. And we're going to I'm going to ask some questions. And the question is always the same in this chapter. It starts with, what is the probability that if a student here is selected at random, that the student's name begins with the letter A. And when I say the name, I mean whatever is written on the screen. So my name begins with the letter L because it says Larry Green. Okay. So what we want to do is we want to come up with strategies to come up with probabilities like this. And I'm starting out with one that's pretty easy, I hope. What you have to remember is that probabilities are fractions. Okay, whether you like fractions or not, a probability is a fraction. Okay, whoever has a black screen turned on, can you turn the video off? Video is probably not the problem, it's probably the microphone that's the issue, possibly. So a probability is a fraction. And hopefully you know from fractions there's a numerator and a denominator. And the numerator of the fraction corresponds to the number of ways that the event that's described can happen. So in this case, the event is the person's name starts with the letter A. So you just go through and you look at all these names. First one starts with, I'm just going to read left to right and then down. Starts with a Z and then an L and then a 1. That's definitely not an A. And then an R. And then Allison, you start with an A. So we got 1. So it's literally just counting. Now the counting can get hard. So we got Allison. And then as we read, we got Elena. So that's,
no, someone is on the other thing.
All right. So by the way, if you don't want to ask a question, you should have your mute on. It should be muted. If you do want to ask a question, then ask. Okay, so we got Allison, we got Elena, and we got Alejandra. We got Aniceto. And by the way, I apologize if I don't know perfect pronunciation. I'm doing my best. And then we have Abigail. So I count 5. Do you everyone agree with me? Okay, so that means the numerator is a 5. Okay, I forgot to hit enter so you could see. So what we can say is the probability of, I can just call it A, because it's the first letter is A, and you can't see it, but I'm typing P, paren, A, N, paren, is equal to, and then a numerator of 5. The denominator are all the total things that could happen. In this case, the things are all the people in the room, in the Zoom room. And the nice thing is it's nice and square. This is a, what, 4 by 1, 2, 3, 4, 5, 6. That's 24. Does everyone see that? So the probability is 5 over 24. Anybody lost on kind of a basic probability question? Any questions on that? Clear so far? Okay, so now let's what I'm going to do is I'm going to get more and more difficult as we go, and I'm going to use your names, and hopefully you stay on, by the way, so that we don't lose you. Otherwise, our whole count's going to change. So let's do a different one now. How about the probability that the letter starts, so the first letter is a vowel, or starts with the letter K. Okay, so now we have the word or, and or is really important. Or is a very important word in probability. What or means is either the first or the second or both. So what that means is we're going to count all the vowels and all the Ks. And we're going to take a total count. Now the denominator is still going to be 24 because our total number of possibility, that's everyone here, that's still 24. So you just got to go here and count. A, E, I, O, U, by the way, we'll call vowels. Okay, because we don't have any Y's and W's. That makes it easier for us. Okay, and so we got, let me go through. Allison, Olga, Elena, Alejandra, then we have Aniceto. That's right, you count this way. And then we also have Abigail and Kaylina. We had another one that left. It used to be an extra. It used to be 2 Ks because I looked at it, there were 2. But for now, we have 7. Do you see that? And that's 7. Actually, it's 23 now because we lost someone. Okay, and Alejandro, you were right. And I'm right. I know that sounds weird, but we lost someone. Before we lost someone, it was 8 out of 24. That was my original idea.
I forgot the chicken on your plate. I'm sorry.
Any questions?
Yeah.
There we go. I just muted Gabriel. Gabriel, if you have a question, you can unmute yourself, but we were hearing your conversation. Okay, so any questions on some of these basic probability questions first? Okay, let's do some that are things that happen in Tahoe a lot. You're all familiar with these guys, right? So these are 2 dice. And by the way, there's 6 sides, if you're not that familiar with dice, on dice. And I don't know how many of you are from Tahoe, but that's a big deal in Tahoe because what's one of our big industries in this town? Yeah, casino. And by the way, I have made a lot of money on both sides of the casino. Okay? One side being a player until they told me they were going to kill me if I came back. And the other side working for them to stop the players from winning. People like me. So both ways made me a lot of money. And both involved a lot of probability and statistics. And if you're really good at it, then you can make some money, although not anymore because I stopped it. But I made money doing it, so don't get mad at me. So, but let me explain some of the probabilities because it's easy to understand with dice. At least a lot of people can do it. So if I roll 2 dice, and I say, what is the probability that the first die is a 3 and the second die is a 2. So a probability of first is a 3 and second is a 2. Okay, so this is a little hard. So before you jump to the answer, let's think about it very carefully. Again, remember my warning about chapter 3. Remember my warning? It's hard. Okay, so let's go slow. I'm going to start with the denominator because the denominator is the easiest here. Okay, so in the denominator, well, let's think about all the things that can happen. Actually, the numerator is pretty easy. But you could have a 1 for the first die. You could have a 1 for the second die. Is that clear? You could have a 1 for the first die. You could have a 2 for the second die. How many different 1s for the first die are there? How many events have a 1 for the first die? There's at least 2, because you could have a 1-1 or a 1-2. What else could you have? Right? A 1-3, a 1-4, a 1-5, a 1-6. There's 6 of those, right? Does everyone understand, Zach? Do you see why there's 6? Ross and Bailey, you get it? Okay, well, if I did the same thing with the first die being a 2, there's 6 of these. Do you see that? So that's 6 times 2 so far. Well, there's 6 different first die rolls. So it's going to be 6 times 6. So the denominator is 36. It's not 12. Any questions on that? Any questions? Okay, the numerator is quite easy because I told you the first is a 3 and the second is a 2, and there's only one way of that happening. Is that clear? So what we can say is that probability is equal to 1 over 36. Any questions so far? Okay, now I'm going to pull out the other part. What else do you do in a casino in Tahoe besides dice that I can pull out? And no, I can't pull out a slot machine. Yeah, cards. Okay, and I don't expect you to know any of the rules of cards. The one thing I will tell you is, and maybe I'll ask you, how many cards are there in a deck? This is a standard deck, but I'm not cheating. Yeah, it's 52 cards in a deck. So if you didn't know that, you know it now. There are 52 cards, and there are 13 different types or levels of cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay, and obviously, because there's 13, 52 divided by 13 is 4. And so there's 4 aces, for example, those are suits. So now I have a question for you. I'm going to pick a card. I'm going to look at it. I'm going to take that card, watch carefully, and I'm going to throw it over there. Now I'm going to pick a card, and I'm going to look at it. So this is actually different than the dice, and I'll explain why in a bit. What is the probability that both of the cards that I picked are aces? So a probability of 2 aces. Okay, so this one's a little hard. We need to look at this one at a time. Okay? Okay, so let's start out with the first ace. So with this first card, what's the probability the first pick is an ace? How many aces are there? There's 4. Yeah, Ross has it. There's 4 aces. There's 52 cards, so it's 4 out of 52. Any questions on that? Okay, so that's the first thing to think about. Then we got to think about if this first card is an ace. If it's not an ace, you already lost. We need 2 aces. If this is an ace, what's the probability that the next one's an ace? And the hint is it changed. Yeah, it's 3 out of 51. Because we know it's not this one ace. So that means we took 1 card out of the deck. There's only 51 cards left. Not only that, we know this is an ace. So that means that there's only 3 aces left. So it's 3 out of 51. That's a good question, Charles. Do we want to simplify to 1/17? My feeling is no. And the reason why is you want to tell the story. And if you look at 1 out of 17, it's really hard to see where that came from. Like if I just said 1 out of 17, it would be very hard for you to come back with there were 51 cards left. Do you see that? So typically what you do is you don't reduce the fraction, which most of you will like that. But what you often do is turn it into a decimal using a calculator. And I hope you know how to type things into a calculator and make a decimal out of it when you have fractions. Okay, then we have something called the multiplication principle. So let me type that in the chat box. The multiplication principle says the probability of A and B is equal to the probability of B, of A, times, I'm going to use an asterisk for times, the probability of B given A. So I'm going to type it fast so I can enter it so you can all see when I entered it. Okay, so A and B means both happen. So what you do is you find out the probability that the first happens. Then you find out the probability that the second happens with the knowledge that the first happened. And then you multiply the 2 together. Is there anybody lost on what I just said? So why does the number get smaller? Because if I picked it, if this first card is an ace, and I throw it over here, you have a smaller chance of getting another ace. There's only 3 aces left to pick from. What's that formula called? It's called the multiplication principle. That's called the multiplication principle. And the way you read it again is the probability of A and B is equal to the probability of A times the probability of B given A. And in particular, now we can actually compute it. I told you the probability of the first card being an ace was 4 over 52. And I know you feel like reducing the fraction, but it's not necessary. And then times the probability that the second is an ace given the first is an ace. And that's going to be 3 out of 51. Any questions? Did I lose anybody on that? Is my warning starting to stick that this is a hard chapter? Yeah, this is tough. This is tough. But it is really important, not just for playing cards, but it's important for all kinds of things. Any questions so far? Let me do the next example. Hopefully you can all see what this is. Kind of upside down. There we go. That's better. So I got a coin. Okay? And you all know what a coin is. I'm going to flip the coin 3 times. 1, look at it. 2, look at it. And 3, look at it. Is that clear? And I want to say, what is the probability that all 3 are heads? Okay, so you type some stuff in. Here, I want to ask you something. Did you use the multiplication principle? Okay, because you type pretty fast. But if you didn't use the multiplication principle, then you weren't getting it. So we need to think about this, but now we got 3 of them. What is the chance on the first flip that you get a head? I hope you all know. 1/2, right? Okay, so it's a 50-50 chance. It's a probability of 1/2 that the first flip is a head. Is that clear? Now, does it matter what the first flip was in terms of the probability for the second flip? Doesn't at all. When it doesn't matter what the first one was in terms of saying what the second one is, we call those independent events. Okay, so those are called independent events. So the nice thing about independent events is that what we can say is the probability of B given A is equal to the probability of B. That's a symbol way of writing it. So in other words, if we know the first flip was a head, what's the probability the second flip will be a head? It's 1/2. Knowing the first flip of the head didn't change your mind, right? Is that clear? So we say they're independent if probability of B given A equals the probability of B. Does that make sense? And those are independent events. So in particular, if they're independent events, this is very easy because the probability the first is a head is 1/2. The probability the second is a head is 1/2. I hope you all know the probability the third is a head. All right, is 1/2. So using the multiplication principle, the probability would be 1/2 times 1/2 times 1/2. What's 1/2 times 1/2 times 1/2? Probably could do that in your head. Times, not plus. Be careful. Yeah, 1/8. 2 times 2 times 2 is 8, not 6. Right, so the probability of flipping 3 heads will be 1/8. Any questions on that? Is that clear? Okay, probability, again, it can get really tough. But it is what it is, and we have to do it. Let me do a dice example. I'm going to roll 2 dice. And we're going to have 2 different events. Let's call A be the event that the first die roll is a 2. And B is the event that the sum is 7. Are those independent? Okay, so here's the key. You can't tell me until you do the math, right? If you think you know without even looking at it, you're just guessing, and guessing's a bad idea, by the way. We need to do the math, and the math is, let's see what the probability of the sum being a 7 is. That's just the probability B. Is that clear? Okay. Well, how many ways are there of the 2 die adding to a 7? I can get a 1 and a 6. Do you all agree that's a 7? I can get a 2 and a 5. Do you agree that's a 7? See if you can tell me how many different 7s there are. Okay. Okay, let me do some more then. I can get a 3 as the first die and a 4 as the second die. I could get a 4 as the first die and a 3 as the second die. Good, 6. So there's 6 different ways. So whatever the first die is, there's always a second die that's going to get me 7. Do you agree? Okay, and we've already talked that if you're doing 2 dice, there's 36 different possibilities, right? So notice the probability of B, that sum was a 7, is equal to 6 over 36. Have I lost anyone there? Okay, what about the probability of B given A? So in other words, if I know the first is a 2, now I'm going to roll the second die. What's the probability I'm going to end up with a 7 total? How many different ways are there? Yeah, 1 out of 6, because that means I must have gotten a 5 for the second die, and there were 6 different second die rolls. So probability of B given A is equal to 1 out of 6. Are they independent? Are those the same numbers? What do you think? We have probability of B was 6 out of 36. We have probability of B given A was 1 out of 6. Are they independent? Yeah. 6 out of 36 is equal to 1 out of 6. You're welcome to use a calculator if you don't want to do the fractions in your head. But not just welcome, but you better have one if you want to use if you want to figure it out. So always have a calculator with you whenever you're in this class. Okay, or a computer is fine too. You can use your smartphone, you know, just not on the test, but on everything else you can use a smartphone. So these are independent. Now I'm going to change a little bit. What if I say the first die was a 2, and the sum of the die is a 5? Okay. Again, we got to find out the probabilities. So the probability the first is a 2. The probability of the sum of the 5 given the first is a 2 is 1 out of 6. Do you see that? Because that means the second was a 3. Any questions on that? Now, the probability the sum is a 5. Well, how can you get a sum of 5? How many ways are there? I can get a 1 and a 4. That's one way. How many total ways? Let's see if you can put in the chat box. How many different ways are there of having a sum being a 5? Yeah, there's only 4. You have a 1 and a 4, 2 and a 3, a 3 and a 2, a 4 and a 1, and that's it. So that is going to give us 4 out of 36. And 4 out of 36 and 1 out of 6 are not the same numbers. So that would be dependent. Any questions on that? Any questions? All right. That was, okay, so what was that the answer for? Is that if, so A is, first is a 2. B is a 5. Are A and B independent? And the answer is no, they are dependent. Hannah, does that make sense? Because we calculated probability of B, we calculated probability of B given A, and those were different answers. So when I ask you, are these independent, you must do the calculations. 4 out of 36 is the probability the sum is a 5. So I'll type that out just so you can see it. Probability of sum equals 5 is equal to 4 over 36. Okay, because there were 4 ways of getting a sum of 5, there's 36 total 2 die rolls. Any questions on this? Easy so far? I'm just kidding. Yeah. I'll tell you, one of the things I want to warn you is if you're finding this easy, it does not mean it's easy. I know that seems like just, what did I just say, right? Watching me do it is very different than doing it yourself. Okay, being able to do it yourself is much harder than watching me do these. The analogy I like to make is kickboxing. It's very easy to watch a kickboxing match. Do you agree? Try getting in the ring and kickbox. All the easiness goes away. And trust me, I used to be a kickboxer. One of my weird things I did when I was younger. I taught karate, actually. Okay, so probability is just like that. It's not that hard to watch someone else do problems, but it's really hard to do them yourself. Okay, any questions so far? Okay, now what makes it dependent? Because 4 out of 36 is not equal to 1 out of 6. Right, 4 out of 36 is a probability the sum was a 5. 1 out of 6 is a probability the sum is a 5, given the first die was a 2. And if they're not equal to, we say dependent. Any questions on that? And again, you'll practice these, a lot of them, hopefully. Okay, now I'm going to give you an easy one, but I want to give you some new vocabulary. Let's look at event A is the first die is a 1. And event B is the sum is an 11. What's the probability of A and B? The hint is it's easy. So see if you can tell me the probability of A and B. So first die is a 1, and the sum is an 11. Right, right. So the answer is 0. So you're right, Riley, it's not possible, but I asked you what the probability was, and that's the number 0. Okay, when the probability of A and B is equal to 0, because it can't happen. The numerator is a 0 because there are no ways that you can have the first die be a 1 and then add it up to 11. Because the highest, once you know the first is a 1, the highest you can get is a 7. Charles, does that make sense? So that means the numerator is a 0. And 0 divided by 36 is 0. Okay. So when the probability of A and B is 0, we call A and B mutually exclusive. So if I ask you, are these events mutually exclusive? You come up with the probability of A and B. If you get 0, you say yes. If you don't get 0, you say no. But if I ask you, are they mutually exclusive, I'm going to say explain numerically. So I need to see that number 0 or some other number that isn't 0 and not just a yes or no. So you need to have that number 0 or not 0. Any questions on that? Okay. Again, the probability is pretty deep. Let me give you the next one. So my question now is, what is the probability that come tomorrow night, I am going to be a multimillionaire? Now, there's a hitch, okay? You wouldn't know until I show you something. What that is? Yeah, it's a lottery ticket. Okay, so the question is, what is the probability that this is the winning ticket? Okay. Any questions? Let me ask you, have any of you played the lottery before? Okay, so this is Powerball, the way. There's a few different lotteries. Powerball is one of them. And let's go to Powerball. Let me reshare my desktop, or share my desktop, sorry. And let me find it again. There we go. Okay, so you should be able to see Powerball. So the first thing is, we better understand the game. And I'm going to click how to play, because we kind of need that. Okay, find a Powerball. For the Powerball retailer close to home, there's a gas station that's nearby, and that's where I get my Powerball ticket. Okay, I bought three different sets of winning numbers because I was feeling lucky today. Okay, then what it says is pick 5 lucky numbers from 1 to 69. And those have to be different. They don't pick the same number twice. And 1 Powerball number from 1 to 26. That could be the same as the 1 to 69s. Okay, then tomorrow evening, they're going to pick the numbers. And if they pick one of my sets of, I have 3 different sets of numbers. If they pick one of mine, then I will be very happy. I'll donate $1 million to a scholarship. Does that sound fair? Good deal? Because I'm going to have so many millions, I can do that. And not just one scholarship, but for a fund. Okay, so now the question is, any guess on what the question is? Given that we're in chapter 3? Yeah, what's the probability that I won this lottery? So let's start out with the numerator because that's really easy. What is the numerator? What's the numerator here? Okay, let's see. Maybe it's not that easy. You may not have been listening carefully either. How many sets of numbers did I buy? 3. That's the numerator. If one of my sets of numbers wins, then I won the lottery. Do you agree? There's 3 of them. So the numerator is a 3. Let's write that down. One thing I promise you we're not going to be able to do is list all the possible denominator outcomes, all the possible outcomes, because there are millions and millions and millions of them. You can't write a list of them. Is that clear? So we're going to have to use some mathematics. And what we're going to use is a mathematical kind of formula that what it is if you are selecting a smaller group from a large group. So in this case, I'm selecting 5 numbers from the group from 1 to 69. And these are without replacement. So I can't select the number 1 twice. Is that clear? So if you're selecting a small group from a large group, we use what's called combinations. And I'm going to show you in the calculator how that's going to work. And let me, just so I don't forget. So it's 1 to 69. Five of them. And then we also have a mega number, or Powerball number from 1 to 26. So we need that information. I don't want to forget it, so I put it on paper. Okay, so what I'm going to do now is I'm going to reshare. We're going to go to my calculator. I recommend going to your calculator also because, again, it's good to practice. So here's our calculator. Let's just clear out what we had. And I just want to calculate the denominator. In the denominator, what I'm going to do and follow along is I'm going to hit this math button. It must be important, it's math. And you might guess, given that we're in chapter 3, any guess on what menu item we're going to on the top? Yeah, prob. Okay, actually with this kind of calculator, I gotta do something different, sorry. Let me quit and then I'll do, I wanna hit, first I gotta hit the number 69, because we're choosing 5 numbers out of 69. Then I'm gonna hit the math number. I always have to do it twice, it seems like for some reason. Now I'm gonna go to prob, and then I'm going to do what's called NCR. Sometimes C could be thought of as choose. We're choosing 5 numbers out of 69. It also is called combinations. How many different combinations of 5 numbers are there out of 69 numbers? Any questions on that? Then I hit enter, and that shows up. Then I hit the number 5. And then I hit enter again, and that's how many different ways there are of choosing 5 numbers out of a total of 69. Any questions on what I did on the calculator? Again, I strongly recommend that you have your calculator out so you know how to do it. Watching me do it is not the same thing as doing it yourself. But then I need to use the multiplication principle because I also have the Powerball number, and that was 1 to 26. So I'm going to actually multiply by 26. Yeah, there's 5 numbers to choose. That was in the instructions on the California Lottery website. That makes sense? We're choosing 5 out of 69 because that's how you play Powerball. I didn't make the rules. Okay, but what I do know is that the denominator is 292,201,338. The numerator was 3, so I can go 3 divided by 292,201,338. And that's my probability that I am going to be the super multimillionaire at the end of tomorrow evening. Okay, do you think that's very likely, by the way? Shall I just get ready to give that big scholarship? Okay. I want to look at this calculator, and I want to make sure you know how to read it. Yeah, dreams can come true. I will tell you, though, I've been teaching for like this same class for 20 years or so, over 20 years, and I've been buying the lottery every class. Do you know how many times I've won the big lottery? Yeah, 0. Okay, but I did win $4 in the fall. But I paid $6 to win that $4. So it was kind of bad. So just let you know, it's very unlikely. The probability, but I want to let you know also, this is really important. It's a very common mistake that people make. The probability is not, is not 1.03, for example. For one thing is probabilities can never be bigger than 1. Okay, you can't have over 100% chance of winning. Do you agree? So what's going on here on the calculator? Anyone see it? How can you read this calculator and not end up with 1.03, rounding to, 3 significant digits? Yeah, we have to move this decimal. You see this E-8? That's scientific notation. What that means is move the decimal to the left 8 places. So the answer really is 0. Is going to be 1, 2, 3, 4, 5, 6, 7. The first place I move, I don't get a 0, but every other one I get a 0. And then a 1. 0, 3 if you want. If you want 3 significant digits. And that's the probability that this ticket is the big winning ticket. Okay? It also shouldn't surprise you that I've never won because it's not that likely. Any questions? Any questions on the lottery example? Okay, I do want to let you know I can't do every possible type of probability question. So you do need to watch. You do need to watch the long video. You need to read the textbooks chapter on probability and see how probability works. I'm giving you some of the highlights. That's all I can do in the 50 minutes or so that I'm doing this because I want to talk about Project 2 next. Project 1. But are there any questions first? Okay, so now I want to go back and let's share my desktop, and now we're going to go back to Canvas. Well, actually, before I do that, let me type in. Is this the type of problem I could give it on the midterm? I could give any of the examples I give it on the midterm or any of the other examples that you have to do on the homework could be on the midterm. Okay, there's lots of different probability problems. Okay, maybe I'll give one more because there's another kind I want to give. There's a lot of different types of probability. So I think I'm going to do one more share. And this is going to be one of those longer webinars because we have a lot to talk about today. This is, there we go. Okay, so let's do another probability question. Maybe 2 more. Okay, suppose, oops, let me change the font. 20. That 30% of all LTCC students, that's our college, are Hispanic. This is supposed because I don't really know the number. I'm making it up, so don't quote me on anything. Okay. And let's also suppose that 60% take statistics. Okay, finally, suppose, when I say suppose, it means I'm making it up, but just use it. Suppose that 35% of all Hispanic LTCC students take statistics. That's kind of the given stuff. Now we got to figure out what the question is. The question is, find the probability that if a randomly selected LTCC student is chosen, that student will be a Hispanic taking statistics. Okay, I call this, this is my name for it, wordy probability problem. Does it sound like a good name for what this is? It's a lot of words. And the hardest part about these kind of problems is deciphering the words. Do you agree? So what I recommend doing is start with this wordy paragraph before you even look at the question. Take all the numbers that were given and write symbols with probabilities. So let's start out with the 30%. That's the probability of what? %30 is the probability that Hispanic, and I'm just going to use the letter H. So P of H is equal to 0.3. Do you agree with that? Do you understand how I was able to read that and write that down? Now let's look at the 60%. What's that? That's going to be P of, any thoughts? Yeah, that's P of S. And that's 0.6. Okay, then the 35%. What's that the probability of? Not quite. Okay, that's the probability of S given H. Because we're only looking at the Hispanics, and we're saying 35% of them take statistics. So we're saying we're looking at the population of Hispanics only. We're given that fact. Now what's the probability that they're a statistics student? Any questions on that? Okay, now we say, find the probability that if a randomly selected LTCC student is chosen, that the student will be Hispanic taking statistics. So if we don't know what the question is, we're going to have trouble answering it. So what is the question? Any thoughts? It's H and S. I'm not going to write equals question mark. Because we want to find out the probability that the person's both. Do you agree? Right? In order to qualify, they have to be Hispanic and they have to be taking statistics. And that's why the and. Do you also agree that this is going to be hard? Trying to read through a paragraph and come up with all of this. And you're going to be responsible for that. Yeah, so I figure I better do this because you better see the hard stuff. Okay. Now we have to use the formula. And I gave it to you a while back today. And that is the probability, these are different letters, the letters don't matter though, of H and S is equal to the probability of H times the probability of S given H. You remember what we called that? Get a name for that equation? Can you remember? Yeah, that was the multiplication principle. Notice that's not the same. You can't just take 0.3 times 0.6. That won't work. It's the probability of H times the probability of S given H. It's not just H. Probability of H times the probability of S only works if they're independent. Because if they were independent, probability of S given H would be the probability of S. But if they're not independent, you can't do that. So given means that we're restricting the population to this group. What's the probability of this item happening? So we're restricting the population to only Hispanics. And we're saying among the Hispanics, 35% take statistics. That's a given. It means restrict the population to the given. In this case, the given is a Hispanic. And then the rest is easy. Okay, this is the hard part. I think you'll agree, the math is not the hard part. The hard part is the setting up the math. Do you all agree that that's the hard part, what I just did? The rest is boring. That's equal to, and you just type it in. Probability of H was 0.3 times the probability of S given H, that was 0.35. And you could drop it in a calculator and you'll get a number. Hopefully you all agree that's the easy part, right? So once you have set up, once you have read all of this and come up with the right equation, then it's just plug it in numbers and you're done. Any questions on this example? Any questions? Not too terrible? Okay, there are other kinds of questions. And maybe I'll do one quickly. Again, I've realized this is going to be a long one. This will be a full hour. Oh, sorry, I just erased it. Is the 0.3 just from H? Yeah, we never used the 0.3, right? We had a point, what did we? Yeah, we did. Yeah, the 0.3 was the H, and the 0.35 was the statistics given H, if I remember right, something like that. So I didn't do any subtraction. There was no subtraction. It was multiplication. Because it's the multiplication principle, not the subtraction principle. That asterisk means times. Yeah, we never used the 0.6. It wasn't in this problem. It could be in like a part B where you have to do something else. But I only have so much time. There's plenty of problems in the book. There's plenty of problems on the homework that you have to do. There's other problems. Let me do one more type because it needs to happen, or you're going to like be really mad that you haven't seen this example. Yeah, I think I need a brush. And then text. Okay, so what we're gonna have is a table. I need some more stuff to write in. You probably guess what the next thing I'm gonna type in. So we have males and females. That's good enough. And there's going to be 3 types of people. There is, let's say, California. The California born. US, not California. Born and other. So foreign. Let's call it 4 for foreign. Okay, so this is what's called a contingency table. What this means is that, for example, the number 17, that means that in the population, there were 17 females who were not born in California, but born in the United States. Do you see how you read that number? So the number 15 would mean there were 15 males that were born in a foreign country. So the question is, find the probability that a student is, or I guess was, born in California or male. Okay, so that's another type where you're given tables. Okay, and to do that, what we can do is we can just count the Californians. How many Californians do you see there? Yeah, so it's 32. How many were born in California? How many people were born in California? Oh, sorry, we got that, 32. How many are male is what I meant. How many people are male? Total male people. There's 65. Everyone see that? Okay, here's the problem though. We've double counted these 20. Do you agree with that? These 20 got counted twice. So we need to subtract the count of both happening. And that's 20. Any questions on that? How about the denominator? How do I get the denominator? It's tedious, but not hard. That's a hint. Yeah, you just add up everything, and that is what? 65, 77, 87, 94, 104 is what I get if I did it in my head right. Probably shouldn't trust me when I do things that fast in my head, though. Any questions on that? And that's it. And then you can throw in a calculator. I'm assuming you know how to use a calculator. Any questions at all on using tables to find probabilities? I realize I better show you this because this is an important one too. There's a lot in this chapter. This is all one chapter. Okay, next, I want to talk about the project. So let me get there. That was that one. That one. There we go. Okay, so the first thing is, if you go to the syllabus, I think that might be the easiest way of getting there. And I scroll. And I click on Project 1. Okay, again, this is Canvas. You can get into this. These are the requirements. Now, I'm not going to read through every word of this. I'm going to let you read through all of it, but I want to kind of give you the idea of what you're supposed to do. Okay? Number one thing, which most of you have done already, what were you supposed to have done last week? Which is very important. Yeah, get partners. Okay? Or part-tenor is fine too. Yeah, actually, Actually, I like partners better than partner. So if you can find 3 in your group, that's better than 2. Because with 2, that means you're going to have to do half of it instead of 1/3 of it. And the other thing is if your partner, for some reason, something happens, they drop the class or something, then you're screwed if there's only 2 of you. Is that clear? So I strongly recommend 3. 2 is allowed, but not recommended. Okay, then what you have to do is you have to come up with your project idea. And what the project involves is conducting a survey. You're going to have to survey people. Okay? And you're going to have to use either stratified sampling or cluster sampling. What I have done for you, if you click on the stratified sampling link, I gave you some notes about stratified sampling and common mistakes. I strongly recommend you read through that. Again, I'm not going to read it to you because that's just wasting your time. You should be able to read that. You don't need a webinar for that. And similarly, if you can do cluster sampling, there's a link for that one too. So I've created resources so that'll help you in how you do cluster sampling and how do you do stratified sampling. We talked about it last week. Any questions so far? Okay, so you have to do that. Here's what I recommend doing. Within the next week, I strongly recommend you come up, first thing, you better have your partners, and come up with your project idea. What survey question are you going to ask? And how are you going to do your sampling? Okay, a requirement of this project is the variable has to be quantitative. You guys remember what that means? What does quantitative mean? Yeah, so what I recommend, ask your partner the survey question. If out of the partner's mouth comes a number, that's good. If out of the partner's mouth doesn't come a number, it won't work. Got it? Okay, ask the partner the survey question. Write down the survey question that you can ask everybody. Ask your partner, make sure your partner has a number answer. Okay, that's a biggie. Because if they don't have a number, it won't go well for you, this project. Okay, any questions so far? Okay, so what you should do is once you have decided on your survey question and how you're going to do your sampling, post it on the Project One discussion board. I will look at that post and I'll let you know if it's going to work or not. Again, I want to help you. I do not want a disaster happening. And the disaster is when it's not going to work. Okay, so if you think you're going to be able to, ask 10 people from every country in the world, it's not going to happen because you're not going to be able to get to every country in the world, for example. Okay. I don't have a deadline, but I'll tell you something. The later you wait, the harder it's going to be for you. Does that make sense? Because you're going to have less time to do the project. Hopefully, at least those of you who have been paying attention, how long does it usually take for me to get back to you on any questions? Yeah, so it won't take long, okay? I have a weird personality, and most statistics students like that part of my personality, and that is I don't like to wait for things, okay? I like to just get it done, and I'm helping you out by getting it done right away, okay? So within a few hours, unless it's like after 9 o'clock p.m., and then it might be within 8 hours or 7 hours, because then I'll get back to you when I wake up. I woke up at 3 this morning, just to give you an idea. I have a weird schedule. Okay, but definitely within a day. No problem. Any questions on that? Don't wait until, a day before the project is due. That's ridiculous. I recommend doing it within a week for sure. Okay, I didn't mention, let's go back one. Project is due May 5th. That's strict, by the way. If you ask for an extension, I will say no. Okay, So try to not like get it ready by late May 5th, because then bad things could, trouble could happen and then you're stuck. So you need to get it done right away. Okay. So at least May 4th is what I recommend having a good goal of. Any questions so far? Okay, so that's what you're going to do. Then once I've okayed it, then you're going to conduct your survey. You're going to ask people. I have a couple rules. One is children can't be asked unless they're college students. The reason for that is it's against the law. And I don't want to go to jail. You don't want to go to jail. Do you agree? So it's really hard to do a survey with children. Don't go to like a 6th grade class and start asking, even if you work in a school, because it's against the law. You have to get written parental permission from both parents. Good luck. Okay, so we're not doing that. So don't do children. The other thing is you must survey more than 30, which isn't that much. Imagine, this shouldn't take long. Imagine if there's 3 of you in your partnership, you each do 11. It won't take long at all. Okay, it usually takes 5 minutes to conduct the whole survey. Okay, maybe 10 total per person. Does that make sense? So you could do 31, that's fine. 30 is not okay. And this is subliminal, but by the way, in a couple weeks, we're going to learn that that's a magic number. But right now, you just have to trust me it is. You okay with that? Okay, so you have to have more than 30 in your collection of data. So it's going to be more than 30 numbers. You cannot use a calculator. You must use a spreadsheet. I highly recommend my spreadsheet. Okay, and not because like I'm, one that thinks I'm the best in the world. I made this really for the project. The first tab, this one, VerStats, which it automatically goes to, that is what you're going to put your numbers in. I want to let you know, if you think you're comparing different groups, think again. This is not about a comparison study. Got it? You're going to ask a group of people one question. You're not comparing 2 different groups. So if you're going to do cluster sampling, you have different clusters. You're not comparing the different groups. You're using the fact that the groups are representative of the population to be able to get one full sample. Okay. The first thing you're going to do once you get to the spreadsheet, after you've done make a copy, I already showed you that last time, is you're going to highlight all the numbers that are there already, and you're going to hit the backspace. And then let me do a survey question with you guys. I don't know if I'll be able to put all of them in, but I'm going to put some numbers in. So let me ask you, this is always a fun one, and you don't have to tell me the truth. How old were you when you had your first passionate kiss? So put in the chat box how old you were, or tell me one or the other. And I was going to type in numbers. So 16. This is so interesting. Oops. Again, I'm not going to put all the numbers because I don't want to waste your time. I'm going to put the first bunch. 16, 16, 21, 14, 16. Okay. Again, you're going to, don't do only 5, by the way. You're supposed to have over 30. Okay. Why I'm shocked, by the way, is I subbed for Wynn, her stats class just yesterday, and I asked the same survey question. There were like almost 30 people in the class. The maximum was 15. And look at you guys. You wait. you had a boring pre-teen time, like it looks like. Okay. So let me just show you what you're going to have to do in this project. You're going to put all the numbers. You are going to look at the statistics. So we have a minimum of 14. We have a mean of 16.8. We have a sample variance. That's not going to be used, so don't do that one. You're going to have a sample standard deviation. That is used, and that's the most important of all of them. Okay, you must have a full paragraph talking about how that can be used. So take that note. That must be, I take off an entire grade if you don't. So you can't get an A in the paper without a full paragraph on the sample standard deviation. And not the mathematics of it, because the mathematics hat was behind the scene. We have a spreadsheet. Median, that's important. Maximum, that's important. Q3, important. And was there sample size, that's important. And Q1, that's important. Any questions so far? Okay. These guys, you haven't learned yet. Don't even think about it. Don't do any of that. But this one is important. The z-score. So the z-score, for example, for the number 21, what you're going to do, see where it says change this? And you used to have that there, but so many people wouldn't change that number. And don't just use whatever's there, use what's interesting. So let's find out if the maximum is an outlier. So if I type in 21 and hit enter, the z-score is 1.68, or maybe 1.69 rounded, and that's less than 2 and greater than -2, so it's not an outlier. Do you see how that works? So that means that's not such a big unusual value. Similarly, if I did the z for 14, that's a low number, the minimum, I get -0.9, -1 basically. Also not an outlier because it's not less than -2. Any questions on that? So you're going to pick z-scores that are interesting. Definitely the max and min, and if there's something else interesting, you can use that to go through the z-score. IQR, that's important, and that's just Q3 minus Q1. That's the middle 50%, the range of the middle 50%. Okay, and then the mode might be interesting. You know what that is. None of the other stuff is important for this project. Okay, so you're also going to have to do charts. The histogram will just show up. Then you also need to go to, if you go to stats, you do box plot. It's not going to be very interesting because I don't have very many numbers here. Okay, there's not much about box here. Maybe I should put more numbers in because, again, with only 5 numbers, there's nothing interesting. Let's put in 14, 16, 13, 16. There we go. And now if I do the box plot, it gets a lot more interesting. And that's stats, box plot. By the way, when you do this, it's going to give you all kinds of security warnings. I don't give viruses, so just say it's okay. There's the box plot. I want you to fully interpret the top box plot. I want you to fully interpret the histogram. There's a stem and leaf plot. Okay. And the stem and leaf plot is not that interesting in this case, but it will be for your data because I don't have a big set. And you should interpret that also. But when I say interpret it, let me go back to the requirements. One of the things that you must do, and let me find it. Put it in here somewhere. There we go. Someone might contract you to do this study. So you and your project must identify who your client is. Okay, and that doesn't mean in reality, okay, I don't expect you to really get paid for doing this, but somebody would pay you. If nobody's interested in what you're doing, it's not a good project. Okay, so people that might be interested, like if you're doing something on college students, that might be, say, the president of the college. If, let's say you work in a restaurant and you want to find out, I don't know, how much people are spending at your restaurant, well, that might be the wait staff because they're getting a % of the amount they're spending, right? And they care. Do you see that? So you have to identify who would care about the project. And then comes the interesting part. I showed you all the things you have to find, but it's not just finding. That's the easy part. The more important part is how is your client going to use that finding? What decisions will your client be making because you found out, for example, the mean age of first kiss was, say, 16? You see that? Okay, and the interesting thing, the mean age of first kiss in the other class I talked to, it was 13 years old. So your client might be, say, the middle school, maybe the middle school principal, and then you would recommend to the middle school principal that there needs to be sex ed for 7th graders so that they're ready when they're getting into their passionate kisses. Okay? On the other hand, this mean, what we got, where was it? Was almost 16 years old. So middle school, for this sample, if this was what we thought the population might be based on the sample, you might say, well, maybe the middle school is a little too young for sex ed. Maybe you should wait around until their freshman year. Do you see what I'm talking about? So if you don't have a recommendation based on every one of those statistics, so for example, we have someone who was 13. So that means we better be ready. Do you see that? We better be ready at middle school because at least some of the kids are getting into it. Any questions on that? But not most of them. Okay. What did you call the Z-score? I called it the Z-score. I'm just looking at your chats. It's called the Z-score. So I know it's a dumb answer to your question, but that's what the Z-score is called. It's called the Z-score. And what it does is it tells you how unusual something is. If it's a high number, it's far from 0, it's unusual. If it's positive, it's unusual on the high side. If it's negative, it's unusual on the low side. Full paragraph of what? Full paragraph of the sample standard deviation. Okay. So again, most of the writing is about the recommendations. Okay. This is a paper, an essay. So it should be an essay kind of form. You should have an introduction. You should have a body, and you should have a conclusion. Your conclusion needs to include the recommendation based on the most important pieces of your findings. Your conclusion should, if what you have in your conclusion could have been written before you even collected your data, then it's not a good conclusion. You haven't concluded anything of your findings. So it should be a conclusion about your findings, not about theoretical stuff. Does that make sense? Okay. So again, introduction, body, conclusion. Let me go back. You should compare and contrast the charts. For each of charts, talk about how your client is going to use it and react to it. What decisions we made after seeing that chart. What chart is better in terms of information given? What this chart gives this information, this other chart gives this other information. What decisions will be made from the different charts, and they might be different. Okay, I'm going to let you read up on this. It's in the book. It's also in the long video, The Empirical Rule of Chebyshev's. You should look to see if your data follows the normal distribution. And not exactly, but is it somewhat normal looking? Or is it maybe skewed left or skewed right? Those are the typical distributions. If it's not perfect, but it's close to normal, that's good enough to be normal. Okay, any questions on that? Okay, again, I'm going to let you read through all this. You should also talk about how you would modify or improve on your study if you had a lot more time and resources. Can you explain the recommendation? Which recommendation? There's a lot. I mean, the whole paper is about recommendations. So you're going to, based on every single statistic, every single chart, You're going to say, what are you going to suggest to the client after having seen that information that will help the business or the students or the country or whatever your interest is or your client's interest is. And you do have to identify your client at the beginning. Okay. Oh yeah, all this is part of the, everything I say is part of the essay. There's nothing else in the paper other than the essay and your name. Don't forget put your names on the project. A quickie, only one of you needs to turn in the project onto Canvas because all three of your names are going to be on it and you all get the same grade. Okay, so there's one grade for the group. So hopefully you get along together and you're all doing your work and you're all contributing. The other thing is, and I mentioned this at the orientation, but I want to remind you again, this is on syllabus. If you can get me the project, email me is the best way to do it. Don't take your draft and post it onto your Canvas because then that's your final submission. Email it to me. So if you can email me your project by Thursday at 8 a.m. before it's due, better be Wednesday, by the way, then I will look it over and give you a full, or at least a partial, set of suggestions to make improvements. Okay, and I'll say, here's 10 things that you can do to make your project better. Any questions on that? Okay, if you wait till after, it probably isn't going to happen. I want to remind you, it sucks, but I have no choice in this. The day before the project is due is the one day I'm not going to have internet access. Sorry. So unfortunately, May 4th, which is May the Force be with you day, which is the day before the project is due, I will be offline. Sorry about that. It's not to be mean. I'm in charge of this huge workshop for all of California, and I'm not going to be able to help you guys. So get this stuff done early. I only read your rough draft once. Don't keep sending it to me because there's a lot of you. I don't have time to read, each draft 10 times or something. That would be thousands of pages of reading, and typing because I got to type in suggestions. So if you have questions after, then post them on the project discussion forum. Post your questions. I need to give you a secret word because I haven't done that yet. So let's do that. Let me do that. I can just, where is it? I think the easiest is reshare. Go back to Zoom. That's the easiest secret word spot. It happened? Didn't look like it happened. Let's try again. There we go. Okay, so secret word. Is given. Because remember we had the probability of A given B. Do you remember doing that? So I was trying to pick something that you probably wouldn't guess if you just randomly guessed words. Probably wouldn't have guessed the word given, but given was an important word in this particular webinar. Okay, so do we post the question on Canvas for you to agree with? Yeah, so on Canvas means a Project One discussion forum. So that is, let's reshare. So you all have a secret word. We're about to lose it. So given. And that was, I think I'll find it. I think it was that one. If you go to discussions, Project One discussion forum. Looks like someone posted since I looked last, which was just before the webinar, I think. Or maybe before my meeting. And then you just post. And it'll show me that someone new has posted, and I'll give you an idea. And then, by the way, look at other people's posts, because you'll get an idea of what other people are doing, what other groups are doing. And that helps. So Charles, you're asking about the secret word. Okay, so the secret word doesn't give you points for the class for doing it. But if you don't do it, for each secret word you miss, I take 5% of your course grade away. So if you don't do any of the secret words, you fail this class. Does that make sense, Charles? And I'll do that by hand. Yeah, so the secret word is very important in this class. So it's not a you get points for doing it, it's you get destroyed for not doing it. So do it. It's not something that you have a choice in the matter. But again, you don't have to come live. You can watch this as a archived video. It is 7:30, and I promise that I try not to make this longer than an hour and a half, but I will always answer questions until you're done asking. This is one of the longer webinars because chapter 3 is really hard, and the project is something takes some time to talk about. The week isn't necessarily hard, just chapter 3 is hard. Okay, if you have a comment, I'll look at your comment or whatever. And by the way, about next week, if you post your thoughts about what time you want the webinar, I'm probably not going to do it on, I enjoy how your calculator has a battery indicator. I've never even noticed that. That's funny. Because, it's not very important when you're at the computer doing it, because there is no battery. But yeah, it must be that particular version that it's modeling has a battery indicator. My suggestion, by the way, for the midterm is bring batteries with you. Bring fresh batteries. So if your batteries die, you got batteries. Good suggestion for the final also. Saying the quiz isn't open yet? The secret word quiz? All right, let me quickly check. That's week 2. Yeah, I'm going to week 2, chapter 3. What is it? Secret word quiz. No, April 21st it closes. It should have been open. It never had an opening date. (2018). Let me double check. Secret word. So if you go to modules, you go to the secret word quiz. Let's click on it. And I'm going to get an edit. You don't have the edit ability, but I'm going to be able to look down and see. No, it says 2019. Yeah. One essay. Yeah, you only have one essay. And by the way, the spreadsheet, I didn't mention this and it's important. You must copy and paste the important parts of the spreadsheet onto your project. If you don't know how to do that, if you have a PC, there's something called the snipping tool. If you can't figure out how to copy and paste, snipping tool, you can grab any screenshot. It's a good thing to know, not for this class only, but for anything on computer. And the Mac has something like it. I don't know what it's called on the Mac. Sorry, I'm not a Mac person. But there's something like the snipping tool on a Mac, where you can take a screenshot and then copy whatever you've taken and then just paste it right into your project. And that could be in a Google Doc. It could be in a Word document, whatever your group wants to use. But you have to show me the spreadsheet that you used. And the important part means this stuff. So the statistics part. This part, and also the histogram, the pictures also. The histogram and the stem and leaf and the box plot. So those have to be in your project. You choose where to put them. I don't care. You can put them at the end. You could put them in the middle and then talk about it on your project. That's up to you. This quiz is no longer available as the course has been concluded. Let me check something. Let me make sure you're in my class, in the right class. Hope you're not in the wrong class. Let's go to people. RUPLEY, right? No, you're in the class. You're in this class, because I do have some classes that have concluded. Yeah, other people said, that's why I was checking to see if it's you. And you're in this class, it should say it's okay. So now I'm pretty confused why it would say that. Yeah, it's working for everyone else. So I'm not sure, Gabriel. So it says you're in. I checked the other people can do it. Maybe you clicked the wrong class. Maybe you were in another class. Did you take another statistics class, Gabriel? Have you taken another statistics class? Like and not passed it, for example, or not finished it?
No, I've never taken a statistics class before.
Okay, because I was thinking maybe you took it and dropped it and you're trying to get your old one.
Nope, it's your class. I've been submitting the homework. Like I was doing my other homework while I was listening to your lecture.
So you're able to do everything else, just not the secret word? All right, well, email me the secret word. Email me the secret word and I'll put the point in for you. I could definitely.
Because like I can reach like I can like what is it called? Refresh my page and then try it.
You could try that too. But if it doesn't work, just send me an email with the secret word and I'll put the point in for you so that it's logged in. As long as you can get the other
thank you so much.
The secret word is the easiest one for me to do for you. I can't do the homework for you, but I could do the secret word for you. And I have no idea what's wrong. Sorry. Because it's working for everyone else. You're in my class. I have no clue. Sorry.
It's okay. It's just my luck.
Yeah, sorry about that. Like I said, technology does weird things sometimes. Any other questions? Let's see. Is the last day we can take the midterm April 29th? So the last day you can take the midterm, just a minute. I believe that's the day, but we have to look. Go back to syllabus. I don't want to quote anything because I don't have everything memorized, but it's in syllabus. May 29th, not April 29th, May 29th. Yeah, big difference. Yeah, May 29th. There is a kind of like an online midterm, that's a whole different thing. Okay, and that might be the one you're talking about, and that can be taken online. You can take that from anywhere. That's not proctored or anything. You can take it early. I think you're talking about that one. So that's not the that's the online kind of exam, you might want to call it. Different than the midterm. And that one doesn't need a proctor. You can do it in Hawaii if you want. You know, and by yourself. You could do it early too if you want. It is long though. I will warn you, it's a long one. Any other questions? Again, I'm here to answer any questions you have. This is a good time. Let me see if I missed any. Because I was helping Gabriel. So far, that's it. If there are questions, just let me know. There's a lot of you still here. And I'll let you know after this weekend, the next couple weekends, I'm going to be doing conferences that I'm in charge of. Those are my busy times. So weekends are going to be tough for me to answer questions, do quick little things, but not long stuff. During the week, I'm here a lot. And then, so this weekend, I'll be around a lot. And then the next 2 weekends, I'm mostly out. Sorry about that. But we all have other things going on. And I'm hoping to be out Memorial Day weekend. I really want to go backpacking. We'll see if the snow is around. Any other questions? Again, I'm here to answer questions, or you can say goodnight, either way. But I'm looking at the chat box. You can also talk if you want. And this will probably be archived. Might be tomorrow morning. Since it's gone a long time, it takes longer for YouTube to process it. And there's two processing that has to happen. YouTube and also the Zoom system has to process. So that takes longer. I'll probably be sleeping by the time it's done. Okay. Okay, have a wonderful week. Wonderful week. Anyone else? Okay. Well, I think I'm going to say goodnight, unless you have something quick. Crystal? And for all those who are watching this as an archived webinar, don't forget to put the secret word in the secret word quiz. And please post on the Project One discussion forum your idea for the project, and I'll let you know whether it works or not. And other questions on the Q&A forum, I'll be happy to answer. So take care. And post on the Q&A forum requests for next week. I probably won't do it Tuesday at 6 because I don't want to shut somebody out if they can't make Tuesday at 6. So post requests, and I'll see if I can do that. So have a good night.